The video you are about to see demonstrates the application of SEALMAKER International's EnviroSeal differentially activated sealant. This unique sealant remains liquid until exposed to the differential pressure and shear encountered at a leak site. EnviroSeal is unaffected by system flow restrictions and pressure changes en route to the leak, thus eliminating the possibility of plugging of the system internally. After a repair, EnviroSeal can be completely flushed from the system and the repair will remain intact and fully functional at the maximum operating pressure of the system, in this case 10,000 psi. A leak is simulated using an O-ring port fitting. A 2.5 millimeter groove has been cut 90 degrees into the threads to simulate a washout in the fitting. This provides an unobstructed path to an outer O-ring seal, of which 20% of the circumference of the O-ring has been cut away to further simulate additional damage. A hydraulic quick coupling with a spring-loaded ball and seat valve was then screwed over the damaged leak fitting. This coupling will provide flow restriction between the pump and the leak fitting. The O-ring is then oriented and then tightened onto the coupling valve. An autoclave bleed valve was then installed just beyond the leak fitting, and the male quick coupling was then inserted and locked into the female receptacle upstream from the leak. A Haskell pump and autoclave valve manifold is then attached to the leak fitting. Here you can see a close-up of the leak fitting just downstream from the quick coupling. A leak rate of 250 milliliters per minute at 8,000 to 9,000 psi is established by pumping fresh water through the system using the Haskell injection pump. MicroSeal is then poured directly into the pump suction. Because of the flow restrictions present and the need to penetrate deeply at high pressure, MicroSeal is the best blend for this application. The Haskell pump is then actuated and the MicroSeal sealant is pumped towards the leak. The initial pump rate now indicates a leak rate of 400 milliliters per minute. The injection rate is stabilized at 8,000 psi and held throughout the procedure. As the sealant begins to enter the leak site, the pump rate begins to slow as differential pressure begins to build. Transformation of the sealant from liquid to solid is now occurring within the leak channel until the leak is nearly eliminated. The system pressure was raised normally to 9,600 psi from the initial 8,000 psi injection rate. This pressure is held for a brief period to allow for complete penetration of the MicroSeal into the leak channel. Sealant penetration continues to occur at the 9,600 psi injection pressure. After allowing sufficient time for the sealant to penetrate into the leak site, the pump valve was then closed to allow the pressure across the leak site to stabilize. The pressure immediately fell to 7,200 psi, where it then stabilized with no further leakage. The pressure was then rapidly applied to 9,800 psi, and a high pressure seal was immediately established. This pressure was then increased to 10,000 psi with no further leakage appearing. The leak was shut in for 2 hours to allow curing. After curing for 2 hours, with zero leak-off occurring, the system pressure was then bled to zero to test the seal integrity. The bleed valve at the end of the line was open, and the pressure instantly fell to zero, indicating no blockage within the system had occurred. The valve was then closed, and the pump valve was open to cycle the pressure rapidly from 0 to 10,000 psi.
In the poppet valve, the valve is opened.
The pressure instantly increased to 10,000 psi and no leakage occurred. The leak remained sealed at 10,000 psi. The sealant was then emptied from the chamber and replaced with fresh water. The seal pressure of 10,000 psi was bled to zero to allow displacement of the sealant from the line. The pressure immediately fell to zero at both the autoclave manifold and at the pump manifold, indicating no restriction in the line. The pump was then actuated to begin displacement of the sealant from the line. Zero restriction was encountered to displace the sealant.
Obviously, no restriction whatsoever through the poppet valve assembly.
As can be seen, the sealant remains unaffected.
Clear water is now.
After all the sealant was evacuated from the system, the bleed valve was then closed and the system pressured back to 10,000 psi.
The valve is being closed. And the leak apparatus pressured up. (2200 psi). (3,000), 4,000, 5,000, 5,500. $8,000, 9,000,
pressure is increased to 10,400 psi and shut in, with no leakage occurring with fresh water across the seal. After verification that the leak repair is intact, the pressure is then bled to 0. The fitting was disassembled and inspected. Polymerized sealant was easily seen inside both the 2.5 millimeter groove as well as on the O-ring. When the fitting was disassembled, the O-ring came out of compression, creating a split in the polymerized sealant on the O-ring fitting itself. Close examination of the fitting indicates good polymerization around the O-ring seal, as well as deep penetration of the sealant into the threaded 2.5 millimeter groove on the threaded fitting. Inspection of the inside diameter of the fitting indicates that no residue or buildup occurred during the treatment process.